All right, 6.5 deals with exponential and logarithmic equations and inequalities and using them to solve each other. So there's two types of exponential equations. One that we've already worked with, where you can easily rewrite the numbers into the same base. So like 125 is 5 to the third, and that would be equal 5 to the x, so 3 has to equal x. The other type, type 2, you can't write into the same base. So the way to solve it is to take the log or the natural log of both sides and then work from there. So here's an example. If we had 7 to the x equals 12, you take the log of both sides. So you have log of 7 to the x equals log 12. Then use our log properties to bring the exponent out in front. So you have x log 7 equals log 12. Divide both sides by log 7 to get a ln, and you have x equals log 12 over log 7 is your exact answer. So if it asks for an exact answer, you're going to use your log or your ln. And then the approximate answer, 1.277. Just make sure on MyMathLab that you're paying attention to the amount of decimal places it tells you to round to. You can also use a graph. You could put 7 to the x in y1, and then 12 in y2, and use the second trace intersect feature. If you did it on Desmos, you put the two equations and then find the point of intersection as well. If we were solving an inequality, solve like normal, so we'd still end up with our x equals 1.277. Then you can either use the graph. So what were we doing? Less than 12. So the graph, this part's less than 12. So it would be from negative infinity to 1.277 that it's less than 12. Or you could just use intervals. So we could try 0. If we plug 0 in, well, 7 to the 0th equals 1. 1 is less than 12, so we'd get the same thing. It'd be when we're less than our x value, we're less than 12. Those are a couple ways to do it. So even when they get more complicated like this, and you have x's in your exponents, you can still do the same thing. So we start by taking the log of both sides. Then we use our exponent rule to bring the exponents in front. Now everything's all multiplied together, so we can use we can distribute, sorry. So if I did this, we'd have 3x log 2 plus log 2. And then we can do it here too. So it equals 4 log 3 minus x log 3. Now we want to get the x's on one side and the non-x's on the other side. So 3x log 2 plus x log 3 plus log 2, because that's going to cancel. Then we'd want to subtract log 2 from both sides. So that cancels, and we're left with 3x log 2 plus x log 3 equals 4 log 3 minus log 2. Now, if we look here, both of these terms have an x, so we can factor that x out. So we're left with 3 log 2 plus log 3 times x, and then the right side stays the same. And to get the x alone, we're just going to divide, because that's multiplication. So we get 4 log 3 minus log 2 over 3 log 2 plus log 3. So that would be our exact answer. If we wanted to type that in a calculator, oops, that's not a, we would just do in parentheses 4 log 3 minus log 2 divided by 3 log 2 plus log 3. And that would give us negative 0.066. So negative 0.066 is our approximate answer. So I'll bring that all together on one screen so you have it. All right, let's try one going the other way. We're trying to solve for x when we already have the logs. So the first thing we're going to do here is we're going to say, hey, subtraction rule with the same base means division. So this is the same as saying x plus 6 over x plus 2 equals log 3 of x. Since both sides have the same base, the arguments have to be equal. So x plus 6 over x plus 2 has to equal x. We can multiply both sides by the denominator to get rid of the fraction. Then we would distribute. And we have a quadratic there if you look at your x squared. So we want to set it equal to 0. So I'm just going to rewrite this up here. So we want to bring the x over. And then we want to subtract the 6. Now it's equal to 0. So we can tic-tac-toe, factor it out. So we'd have a positive 3 and a negative 2. So 1, 1, 3, negative 2, x plus 3, x minus 2. And then if we made those both equal 0, our two possible solutions are going to be negative 3 and positive 2. Well, if you remember back, your logarithm has to be greater than 0. So because of this x right here, we can't have the negative 3. So our only solution is x equals 2. It's the only choice we have. All right. Graphing calculator. So if you were to graph these, let's see, they do not intersect when x equals negative 3. So if we look at the picture over here at negative 3, they don't intersect. So it's okay that we crossed it out because it's not a solution. So that's how you can graphically see there's only one solution as well. Okay, here's another one. So we're going to do the same idea. This time it's addition. So we're going to multiply 3x plus 2 and x minus 1. Well, remember the base, if it just says log, is 10. So if we rewrote this, it would be 10 to the first equals 3x plus 2 times x minus 1. So remember, that's your base, that's your exponent, that's your answer. Well, 10 to the first is 10. And then if I multiply these out, I get 3x squared minus 3x plus 2x minus 2. Combine like terms. We get 3x squared minus x minus 2. Bring the 10 over because, again, it's a quadratic. So we want it to equal 0. Now we can... This one's not factorable, so we have to do the quadratic formula. So negative b plus or minus b squared minus 4ac all over 2a. So if we wrote this, if we did the math inside the square root, we get 145. So these would be our exact forms. If we did the math out, 1 plus the square root of 145 divided by 6 is 2.17. And 1 minus the square root of 145 is negative. Remember, we can't have negatives. So the only one that works is 1 plus square root 45 root 6. That's our exact answer. This is our approximate answer. All right, now let's look at this one. if we're trying to solve inequality, we're going to start by solving it the same way. We're going to start by making it equal 0. So 0 equals 3 log base 2 of 2x minus 15. So we need to add 15 to both sides. We want to divide by 3 to get the log alone. Now we're going to rewrite this. So our base is 2, exponent's 5, and then that becomes 2x. Well, 2 to the 5th equals 32. Divide both sides by 2, x equals 6. So to make it equal 0, x equals 6. So now we're going to try less than 0. So we have two options if we're doing less than or greater than. We have negative infinity to 6, and we have 6 to infinity. So if I plug 0 in to the original equation, well, 2 times 0 is 0, so we really can't do that. So let's try 1. Because remember, you can't have 1 in there. So if you did 3 log base 2 of 2 times 1 minus 15, let's see. So that'd be 3 log base 2 of 2. And then change of base would be log 2 over 2. Because those 2's cancel out, right? So we really have 3 minus 15, which is negative 12. So when you plug 1 in, you get negative 12, which is less than 0. So our negative infinity to 6 is less than 0. And then 6 to infinity is greater than or equal to. That's why that one has a bracket. All right, natural logs. So here, we're going to reverse our exponent property to get e to the ln. Now remember, log base e is the same as ln. So these two things are going to cancel each other out. So we're left with x to the negative 2 equals 16. Negative exponents end up flipping fractions. So x squared equals 16. Square root of 16 is positive or negative 4. But we can't have a negative, so our only solution is 4. So really remembering those exponent properties are what's going to help you, and the log properties are what's going to help you solve these. So let's look at another one.
Hey, let me know when you're done. I got to kill the internet.
Okay. So right here, we've got an e and an ln that cancel out. So this term turns into ln x. And then here we have ln x minus 3 equals ln 2. Subtraction makes a division problem. And because these both have the same log, we can make them equal to each other. Multiply both sides by the denominator, and we get 2x minus 6. Subtract 2x from both sides. We get negative x equals negative 6. And then divide by negative 1, x equals 6. So that's our solution to that one. All right. So here's another one. Why don't you try this? Well, and pause it, or you can just watch. So if we break this, so if we rewrite it like this, now it looks like a quadratic. Because we have a 2 and a power of 1. So if we solve this, then we can tic-tac-toe. Like this was 1, negative 4, and then 1 times 3 for our a. To get 3, we need a negative 3 and a negative 1. Greatest common factor, multiply, x minus 3, x minus 1. But here, instead of x, we had e to the x. So really, this is e to the x minus 3 and e to the x minus 1. Solve those for 0. E to the x equals 3. E to the x equals 1. Take your natural log of both sides. ln 3 equals x. ln 1 equals x. Well, the natural log of 1 is 1. So those are our two exact solutions for this problem. So anytime it looks like a quadratic, you can solve it. Just remember to substitute the right values back in your final solution step. If we were to graph this, we would find in the figure we see that the graphs of 0 and, oh, hold on, I did that wrong. Natural log of 1, ln 1 equals 0, not 1. So I said that wrong. So this should be 0. And then on your graph, those are the two values you have right there. All right, let's look at a couple word problems. So the strength of a habit is a function of the number of times the habit is repeated. Blah, blah, blah. Here's the equation. Solve for k. So the first thing we need to do is to divide both sides by 1,000 to get the parentheses alone. So we have h over 1,000 equals 1 minus e to the negative kn. So we want to bring the 1 over to get our e alone. H over 1,000 minus 1 equals negative e to the negative kn. We want to get this positive, so we change the sign of everything. Now, to get rid of our e, we take the natural log of both sides. So ln negative h over 1,000 plus 1 equals ln e to the negative kn. Well, that cancels out, so it just equals, where's my eraser? Here we go. Negative kn. And we want to divide by negative n to get both sides the same. So we have negative ln of negative h over 1,000 plus 1 divided by n equals k. So it looks messy, but we've solved for k. That's all it's asking you to do is use the rules to solve for letters. All right, so here's another one. Someone monitored the lifespans of 129 robins over a 4-year period. And here's the equation they got. We want to know how many robins had died after 6 months, which is half a year. So if we use that equation, 2 minus log 100 minus x over 0.42, and we want it to equal a half. So we put 0.5 in for y. So we're going to multiply both sides by the denominator. So we get 0.21 equals 2 minus log 100 minus x. Subtract 2 from both sides. Negative 1.79 equals negative log 100 minus x. Make both sides positive. Now, remember that's a base of 10. So 10 to the 1.79 equals 100 minus x. Subtract 100 from both sides. So 10 to the 1.79 minus 100 equals negative x. So you get 38.3, negative 38.3 equals negative x when you type that in a calculator, which means x equals 38.3. So about 38%, right? Percent, yep. So about 38% of robins died in the first 6 months of the experiment. That's how that's working for you. So that is 6.5. Sorry for the random interruptions, but c'est la vie when you record things at home in the nature of COVID. Let me know if you have any questions.